Yes, good morning, everyone. In the last class, we were discussing about IP version 4. Yes, so in IP version 4, we have discussed that it is of 32 bits. Then it has 4 octets, and each octet is of how many bits? 8 bits, right? Then what we discussed that the total range of the IP version 4 is from 0 to 255. Okay. Or in like when we are talking about 0 to 255, it is first octet, right? So if you want to write total, it is going to be 0 dot 0 dot 0 dot 0, then 255 dot 255 dot 255 dot 255. Correct? Next, what we discuss? See, this IP version 4 has been further divided into public IP and the private IP. So we'll discuss about these differences. Before that, we have to understand that it is going to have certain classes. Yesterday also we discussed that how many classes we have? 5 class. So let's say we have class A. So what is the range of class A? 0 to 120, 7 or 6? 7. Now for class B, what is the range? 128 to 191. Now for class C, what is the range? 192 to 223. Then for class D, 224 to 239. And then we have last is class E, 240 to 255, right? See, when we talk that, okay, in class A, what happens that the IP starting from 0 and IP starting from 127 is reserved. See, whenever the IP is starting from 127 is reserved for what? Loopback IP address, right? And whenever this IP is starting from 0, it means that it is local host. What it is? Local host, or we can say same network. See, whenever like when you will come to one topic, when we'll start one topic that is called as a DAC, or even in the R, when we will capture the packet in the R, so it will show you that ARP request was in what form? 0 dot 0 dot 0 dot 0. So when it is 0 dot 0 dot 0, it means what? It means that it is going to be unknown, right? Unknown in the MAC address, it will be unknown. But here, what we can understand that it is telling you that at present, I don't have any address. So what I am considering here, local host, that is going to be 0. That's why this 0 is reserved for what? Local host, and we don't assign it to the end devices or any devices. That's why we say it is a reserved, right? Whereas you know that what is this loopback IP address? We can say this is like a virtual IP address. What it is? Virtual IP address that is used for testing purpose and verification purpose, right? If you don't have any IP address, and even if you want to check whether I'm able to reach somewhere or not with it from my device, how will you check? Using this loopback IP address. Okay. When we'll start routing, then I will explain you loopback interface. They both are different. This is address, that will be interface. Okay. Now, see, in the class B, we are going to use all the IP addresses, correct? There is no any reserved IP addresses. Same as in the class C also, we are going to use all the IP addresses. Whereas class D is reserved for what? Multicast address. This is reserved for what? Multicast address. See, what is the use of this multicast address? First, you need to understand that part. Now, for example, what happened? Consider here that there was one router, one more router. See, this is what? This is router 1, this is router 2, this is router 3, and this is router 4. Now, what happened that this router 2 has to form the neighborship between router 1 also, 3 also, and 4 also. To form neighborship, what is the option? See, like either he will ask his address, he will ask his address, and he will ask his address to form the neighborship. Don't you think that he require multiple different addresses? It requires no. So better to take one multicast address. Let's say it is going to form neighborship using a protocol that is called as a OSPF. For example, what it is using? OSPF protocol it is using to form the neighborship. It has two options. Either it has to ask individual IP address of the neighbor, then form the neighborship, then or send the information to that individual devices, or if it want to send information to all these multiple devices, rather than sending one by one to respective IP addresses, what it will do? It will send it to one multicast address. And if it is going to send on the multicast address, what will happen? All the devices coming under that will receive that information. So what happens that if you are if we are taking here OSPF, so OSPF will have a multicast address, reserved multicast address. If you are using EIGRP, it will have one multicast address, reserved multicast address, like that only. That's why whatever the class D it is coming under this, so it has multicast addresses that is being reserved for this, right? Whereas this class E is reserved for what? This is for research and development work. It means we are not going to use all these things. So what we will be using always? Always we will be using class A, class B, and class C only. Only these three classes we are going to use. That's all. Right? Till here it is clear? Now we will understand why the range is starting from 0, ending at 127, and same here is starting from 128 and ending at 191. And whatever the number that we have written here, this is the range of the first octet, right? Now we understand that part. Now, first we will write the range of that number. That is 2 power 0 is what? 2 power 1 is 2. 2 power 2 is 4. Let me drop this also. So 2 power 0 is 1. Then 2 power 1 is 2. 2 power 2 is 4. And 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Now you see and tell me that what will happen in the class A. But what we are doing here, we are talking about which octet? First octet. So what it says that the class A is starting from where? 0. Ending at where? 127. It means that if it is ending at 127, then don't you think here that if first octet is going to have 8 bits, it means we will write 8 bits. That is 1, 2, 3, 4, 5, 6, 7, and 8. What we are doing? This is my first octet. And when you will write the first octet into the bits, how many bits? 8 bits. That's why we have written here 8 bits. Now, first, your starting range is 0. Forget this. What is the last range? 127. When my last range is 127, it means that I cannot use 128. Because if I will use 128, what will happen? I will come to class B. I have to be in class A. It means I will never use 128. So what if you are not using it, what you make? 0. So make it 0. You make it 0. Then what will happen? You will fix it. Why you are fixing it? Because see, if let's say all these bits are 1, then you forget this 128 and add this 64, 32, 16, 8, 4, 2, and 1. What the value you will get? 127. It means my last range of class A is going to be 127. It means that I cannot take 128. If I will use 128, I will come to class B. It means in class A, first bit, first bit of first octet is always reserved and it is always zero. This is the first rule. What is the first rule of the class A ranges? Means we know this is a range. Rule says that first octet of first bit of first octet will be always what? Zero, and it is going to be fixed. Right? Now you come to second class, class B. Again, you write the same thing. 1, 2, 3, 4, 5, 6, 7, and 8. Now, see, what is the starting range? 128. If starting range is 128, it means what? That always I will use this 128. I cannot make it zero. If I will make this 128 as a zero, what will happen? I will come to class A. I have to be in which class? Class B. So I have to use this, right? And if I am using this, even I have to fix this, right? Next, what is the last range? 191. 191 in. Now see, what is the second one? 64. If you will make it 64 also up, then you will add 128 plus 64. What value you will get? 192. And if I will get 192, what will happen? I will come to which class? Class C. I have to be in which class? B. So it means even I am not going to use this one and I will make it zero and I will fix this. Rest, whatever we are having, no, we can put any values there, zero or one, anything. That's why I'm not doing anything there. But what we can understand here that for the class A, the first bit will be always zero and it is going to be fixed. For class B, first two bits are reserved. In that first bit will be one reserved, second bit will be zero reserved. Correct? Next, what will happen? You will come to which class? Class C. Now, again, you are seeing here that we will be having 8 bits. So write that 1, 2, 3, 4, 5, 6, 7, and 8. Now, 8 bits we have. Now, what is the value we have written here? 192. It means that to reach 192, you will always use 128 and 64. It means both the value is up, right? But are you going to use 32? No. What will happen? You will come to class D. So we have to make it zero. And even we have to fix that. This will be fixed. This will be fixed. And see, this is going to be fixed, right? Next, 1, 2, 3, 4, 5, 6, 7, 8. This is what we are writing here. Bits of the first octet. What is the range? 224. So if I have to use 224, it means that I have to use 128. Yes. 64. Yes. 32. Yes. But what is the last range? 239. It means I cannot use 16. If I will use, what will happen? I will come to class D, class E, that is having the range of 240. So it means I have to make it what? Zero. And again, I will fix all this. Right? And what is the last one? So again, you put 1, 2, 3, 4, 5, 6, 7, and 8. And the total 240 it is. So we have to make it all one here. 1, 2, 3, and 4. 240. And what is the 255 last? So we can make it all one also. That is fine. But I have to be in this class E only. That's why I have to reserve all this first 4 bits. This is the criteria. And this is how we are going to have each classes a separate range where certain bits will be reserved. Clear? Everyone? Online students, clear?
Yeah.
Then we have discussed this ranges. Now I told you to read about this. Have you read? Ayana, have you written the full form? Okay, after the class I will check. So next, before coming to submitting part, first we will understand differences between private and public IP. Okay, let's write first. First we will write here public IP. Who gives this public IP? See, it is used externally to reach the internet. Why do we use this public IP? It is used to reach internet and it is used externally, right? Next is what? Next point. It is unique. It means that always your public IP address would be unique, right? Next is what? It is given by ISP, right? Then, okay. Apart from that, any other things? It is not free of cost. You have to pay for this, right? Correct. Next is what? If private IP address has to map with public IP address to reach the internet, then NAT is required. What is NAT? Network address translation. Okay. Network address translation. It means that just with the help of public IP addresses, we cannot reach the internet, right? What is required? Even one more thing is required, that is called as a network address translation act. Right. So that's why we have written here unique, because it is going to be a single public IP address available for multiple different private IP addresses to reach the internet. For example, let's say in a Wi-Fi network, you will find that let's say we have so many devices, right? End devices. So you have to check the private IP addresses. And when will you check the public IP addresses? No, on each devices you search on the Google, what is my IP address? When you will search what is my IP address, you will find that all the global IP addresses is the unique same for all the devices. Let's say I have one laptop, one mobile phone. Let's again certain other devices. All these devices is connected to a single Wi-Fi. So who is enabling all these devices to reach the internet? That single Wi-Fi connectivity. That Wi-Fi connectivity is going to have what? One public IP. And with the help of that public IP only, all the devices located in my network is able to reach the internet, right? So though you will be having this different unique private IP, but public IP will be same single, right? Now, how will you how it is going to manage this? With the help of network address translations. Okay. So in that, what happens that there will be multiple end devices are there that is going to access the internet using a single public IP. So how to differentiate the traffic based on the different port numbers? Okay, based on the different virtual port numbers, they will be differentiating with the traffic. Because see, Okay, let's say we are able to reach the internet, but all the users are not going to use same servers. No, they may access some other websites. They may access some other websites. So how to identify that this particular traffic belongs to this particular end devices? Based on what? Port numbers, right? Next, what about private IP address? Who give this? It is assigned by network admin statically, or the device will get it automatically from the DHCP server. Okay. Now, what is the reason? See, always it is not possible for the network admin to assign IP statically because there are so many devices. That's why what it prefers DHCP server. What is this DHCP? Dynamic host configuration protocol. Okay. We'll discuss this. We'll do the configuration also for the DHCP. Next, it is not mandatory. See, what we have right here, it is unique in the same network I'm talking, right? Or you can, in simple term, I will write here, it is not unique. Why it is not unique? I will explain you now. See, why it is not unique. Let's say there is one organization. It has used 192.168.1.1 as an IP address for its end devices. One more organization is there. It is also using the same IP, 192.168.1.1 for its own devices in a same network. Now, these two are the different networks, right? Now, they have used 192.168.1.1 and they have also used the same IP. But when they will communicate, what is required? Public IP. So, public is unique, no. Private is not mandatory to be unique. I'm not telling you that, okay, in a same network also you can assign the same IP. No. Let's say you have a net IP of 192.168.1.1. For example, what we did, here we have one IP 192.168.1.1. So this IP is belonging to one network that is called as a 1.0. For example, consider here. Now, maybe what will happen in this network, I may have 10 IP addresses, for example. So if 10 I have, that 10 IP should be unique in my network. You cannot assign two different PCs with the same IP, right? But what I am talking about the same network. But this same network can also be used with other organization also. Why? Because this is private. See, if anything is private, it means what? It is personal, right? They have its own choice, no? But when you have to communicate with outside world, what is required? Public. And it is what? It is unique. So it is not mandatory to be unique. Okay. If organization A is there, it is assigning its IP addresses to the end devices as 192.168.1.1. It is private IP, fine, no problem. And organization B is there, it is also assigning, let's say, one of the devices in its network as 192.168.1.1. It is also fine, no problem. Because when they both will communicate with each other, they require what? Public IP address. And this is what? Unique. Okay. But in this network, only one devices will be getting this IP. In this network, only one devices will be getting this IP. Right? That's what. Now, it is not unique. So we have written here that it is given by whom? Network admin, either statically or by the DHCP, right? DHCP servers automatically. Next is what? It is free of cost. We don't have to pay for this. Next, it is used internally. for internal communication, right? So in each class, whether it is A class, B, or C, in all these three classes, we will be having certain ranges as a private and certain ranges as a public. And you have to remember these ranges. See, this is talking about the public IP range. See, this is what? Public IP range. In which class? Class A, Class B, and Class C. Now you know that in Class A, from IP from 0 is reserved and IP from 127 is reserved. That's why it is starting from where? 1.0.0.0 till what? 9.255.255.255. Then again it is starting from 11. Why? Why not 10? Because IP from 10.0.0.0 till 10.255.255.255 is private IP range of class A. This is what? Private IP of which class? Of class A. That's why here it is ending at 9.255.255.255 and again starting at 11.0.0. So what you can write here, this is what? This is the usable public IP range, right? And this is ending at what? 126.255.255.255. This is for class A. This is the range. Okay, in the next slide, the class A range is written. Next is what? Class B. So in class B, what is the range? 128.0.0.0 until what? 172.15.255.255. And now see this side, what it is doing. It is starting from where? 172.32.0.0 and ending at 191.255.255.255. That is fine. But what about the middle one? So in this, what happens? The class B, the IP from 172.16.0.0 till 172.31.255.255 is reserved for what? Private IP range. Private IP of class B. Hmm. Huh? Hmm. Huh, it is fixed, no? Means you want this one, why it is not 255, right? No, no, it will come to that part. Wait, we'll come to that part. Why it is not 255, second octave? Because it is fixed. Okay, in each class, there is certain ranges and certain conditions also, right? Till here it is clear? Next, see in the class C, what is it in? That IP is starting from where? 192.0.0 and ending at what? 192.167.255.255. So it means next is what? 192.169.0.0 and then 223.255.255.255. So whatever is coming in between them is reserved for what? Private IP. So what is that preserved IP? 192.168.0.0, then 192.168.255.255. This is for this is the private IP of class C. Clear? Clear, no? Clear. Now see the ranges of the private IP range. Same thing it is written, whatever we have written here. And see, this is regarding the class A. So for class A, what is the private IP range? 10 dot 0 dot 0 dot 0 till what? 10 dot 255 dot 255. Then for class B, 172.16.0.0 and 172.31.255.255. For class C, 192.168.0.0 and 192.168.255.255. See, on what basis we have these ranges? See, there is one term that is called as subnet mask. It is used to identify the network and host part of the IP address. What is this? Subnet mask is a number that is used to identify the network and the host part of the IP address, right? Number of one will represent network part. Number of one. One means what? Bits, right? Number of one bits will represent what? Network part. Whereas number of zeros will represent host part or host bits, right? Now see what it says that default subnet mask of class C is 24, or let's say we will write is 255.255.255.0, or what you can write here if you want wait write the number form first is 24. How will you write this 24? 24 means what? 24 1. So slash 24 will be written as 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, rest 1 2 3 4 5 6 7 8. Why? Because total 32. And what we're writing here 24. It means 24 1 will come and rest 8 is going to be 0. So what is the value we'll get? 255, 255, 255 dot 0. So now you tell me network part is equal to 2 to the power. How many ones we have? 24. 2 power 24 ones we have, no? So these are the network part. Next is host part, right? What is the host part? 2 power 8. That is what? Number of zeros, right? It means what? It means that first P octet in class C is network part and cannot be changed, or don't write cannot be changed. Is network part and cannot be assigned as host, right? That's why if you will observe here in this class, this first three is fixed. Where? In class C, I'm not telling that, okay, this will you will get always the same number. No, you will get different numbers, but this is not from your side. Whose side it is? Network side. So this three part will not be used for the assigning the IP addresses. You cannot change this first three part to assign IP to the client. Who will change? Network will be changed, but always the host part you will have to change. It means only you have only one option to change in the class C. And what is that option? Last octet, right? So what you will write in class C, fourth octet is changed to assign unique IP to the client. Getting or not? This is regarding which class? C.
See, Y class.
Hmm?
Y class. You could have done this with class A or
No,
class B or
with A also we have done, B also we have done. Okay, we'll come to that part. See, what happens that in class you can change only fourth bit, fourth octet, right? In class B, you can change third and fourth, both the octet. In class A, you can change second, third, and fourth. That's why, see, when you can change only one octet, it means you have very limited opportunities, right? When you are coming to class B, you can change third also, fourth also. It means you have more options now. When you will come to class A, you can change second, third, and fourth. It means again more options. That's why class A is used for the larger network, class B is used for the medium sized network, and class C is used for the smaller network, right? So whenever at your home, if you are taking any Wi-Fi connectivity, you will find that you have the IP of class C, private IP. Why? Small network, less number of devices. That's why. Correct. So that's why in the class C, first three octet is fixed, and this is the network part. Whereas last one is what? The fourth octet can be changed, and this is called as a host part. So what can be changed? Always you have to remember, network part will not be changed, host part will change. Network part will be changed by whom? Network only, right? Same as we have for the class B. Default subnet mask of class B is 16, right? How will we write that 16? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5, 6, 7, 8. What is the value you got? 255 dot 255 dot 0 dot 0. Right? Then here also network part is equal to 2 to the power 16, because how many ones we have? 16. Then host part is what? Same, 16 only, right? So 2 power 16. It means what? First two octet of class B is network part, okay? And the last two octet is host part and can be changed. So here you are having only one option to change. Fourth one. Here you have two options. Third also, fourth also. That's why compared to C, B is larger network. So what is the default subnet mask of class C? 24. For class B, 16. And we can also call it as a CIDR value. Classless interdomain routing. We'll come to that part. What is a system? The reason, because see, okay, that for class B, the default is 16. For class C, the default is 24. But don't you think for that, before reaching to 24, I will have to cross 17, 18, 19, 20, 21, 22, 23. So all this is part of what? B only. Because from 21, 24 is what? C. Same will be there for the class A also. Till here it is clear? Now we'll write for the class A. Default subnet mask of class A is 8. So how will write that 8? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So value is going to be what? 255 dot 0 dot 0 and dot 0. Right? So in this, what happened? What is the network part? Network part is equal to 2 to the power 8. And host part is what? 2 power 24. 8, 8 plus 8 plus 8, right? 24. So here, what is the option? Like first, octet is network part, and the last 3 octet is for host part and can be changed, right? That's why compared to C, a larger network is what? A. Clear till here? See, then what happened now? Earlier we were using this classful network. Classful means what? Classful means we were using default subnet mask values always of class A, B, and C because D and E don't have any subnet mask, right? Subnet mask we have till A, B, and C only. Now what happened that we were having more numbers of devices. Day by day, numbers of devices were increasing. So it was not enough to handle the numbers of users or numbers of IP addresses. That's why around in 1990, 1990, classless network came. Now what happened in the classless? That as you know that the default subnet mask of class A is 8. But this is what? Classful. Okay. If you have taken the default subnet mask only, the term is called as a classful. If you have taken 9, 10, 11, 12, 13, 14, anything, this is called as what? Classless. Means if you are taking any other subnet mask apart from default one, that is called as a classless network, right? So that's why we have two terms. One is classful subnetting and one is classless subnetting. Classful subnet means what? Subnetting using default subnet mask and submitting using any other subnet mask apart from default one will be called as a classless, right? So, okay, submitting was present, but it was based on what? Classful. But as it was not enough, so what happened? Around in the year 1990, we started using what? Classless subnetting, right? Now, before that, first we'll understand what is the meaning of this term subnetting. Now, tell me what is subnetting? Subnetting means dividing large network into small subnetworks. Okay. What it is telling you? Dividing the large network into the small subnetwork. For example, let's say you have 1000 rupees. This is very big sum. For example, what you have to do, you have to distribute this 1000 rupees into 10 individual. So each individual will get how much sum? 100, right? So each is getting what? 100 as a sum, correct? No? So now this is what? Network. Consider this is as a network and this is as what? Subnetwork. So what you did here, that as we were having 1000 network, so I divided it into multiple 10. Single network I was having, and it was having a sum of 1000. Then what I did, I divided into the 10 different individual networks, and each sub networks was having a range of what? 100. So now this 100 is called as what? Block size. What is this 100 is called? See, it means what? That you have a very large network. That large network you are dividing into the small network. Now that a small network will be having certain range. The range of the small network will be called as what? Block size. Right? Got the idea? First thing, what is subnetting? Dividing the larger network into the small network, multiple networks. Second thing is what? Whatever the range of the individual subnetworks we have, it is called as what? Block size. Now the question comes, why you are doing this? What is a function of the subnetting? See, you tell me, when you divide large network into a small network, what is the first advantage you will get? Oh, simplicity you will get. Then one more thing you will get, controlled access of the network. Controlled access of network, right? Now, let's say you have a requirement of rupees 90 and you have 1000. What you will do rest? You will waste only, no? Huh? So if you have a smaller network, it reduces the wastage. What it does, it reduces the wastage. Now, why it is important to reduce the wastage? Because you know that we are having limited IP addresses, more numbers of users. If I will start wasting the IP addresses, what will happen? Again, I need more IP. Again, I need more IP. So why to waste that, right? So with the help of this subnetting, what is the advantages? Reduces the wastage. Then third, efficient allocation of IP address. Right? First thing, simplicity. Okay, it is very simple now. Controlled access of the network reduces the wastages and efficient allocations of the IP addresses. These are the advantages of the submitting. When you will go for the interview, they may ask you what is submitting and what is the advantage of submitting. Why we prefer this, right? So first, what we will tell, dividing the large network into what? Smaller network, and these are the advantages. Some other point you can add from your side also. Okay, this is your task. You have to add certain other advantages of the submitting. Clear here? Can I rub this? Next, see here. What is it in? Submitting means dividing the network to economically assign the IP addresses. Submitting enhances the network efficiency by dividing the larger network into smaller and more manageable segments, which reduces the congestions and improves what? Performance. So submitting enhances the network security. Isolation of the network segments. First thing is what? Isolation of the network segments by dividing into smaller subnets. It provides you what? Controlled access of the network. Third is what? Improved monitoring and the management of the network. Whenever we talk about the network and whenever we talk about the IP, these are two different terms, right? Net IP belongs to network. IP belongs to network. Same as HSR layout belongs to Bangalore. It means what? Network is broader term. IP is smaller term, part of that network. So when you will come to the routing, okay, so you have to know, let's say we have been given an IP address, but when you have to form the neighborship, when you have to exchange the route, you will not write the IP. What you will write? You will write the network address. That's why it is very important to understand how to find the network address of the given IP addresses, right? So now we will start with the classful subnetting, then classless subnetting, and then we'll understand how to find the network addresses of the given IP, right? Any doubt, any question still here? See, what is subnet mask? It is a number that identifies the network and the host part of an IP address. What is block size? The number of IP addresses or the number of addresses in IP range, or block size refers to the number of IP addresses available within a subnet. Overall, subnetting provides a structured approach to manage and secure the network resources effectively. This is all A, B, and C default. Network part is 8, 24, 16, 16, 24, and 8. Already we have discussed these things, right? Now see, for class A, what is the default subnet mask? 255.0.0.0. For class B, 255.255.0.0. For class C, 255.255.255.0. Network part by 1, host part by 0. Class C, classful subnetting. Okay, we have taken one IP. For class C, you know the range, right? So we will take one IP of private IP. 192.168.0.0, let's say /24. Okay. Now, what we will do? First thing you know that it is /24. For the first time, we will write this. Okay. 1, 2, 3, 4, 5, 6, 7, 8. When you're expert, don't need to write all these things. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 1, 2, 3, 4, 5, 6, 7, 8. So 255 dot 255 dot 255 dot 0. Now, what is a block size? Block size is equal to, see, to get the block size, you will have to subtract from where? 256 minus. Now, why we are subtracting it to 56? Because total range is what? 0 to 255. It means 2 to 256. And each bit is of how many, each octet is of how many bits? 8 bits. And 2 power 8? 256 only. Right? No? You can calculate also. So now, see here. So from where we are subtracting it? 256. Now, here, what is the value? You know that in class C, what we can change? Fourth octet. So if you have changed also, what is the value you're getting? 0 only. It means no change is there. So what you will write? 0. 256 minus 0 is what? 256 only. Okay. Now, after doing this, you have to write the range. What the range I will be getting here. So you have to start from 192.168.0.0. then 192.168.0. Why you will write 0 here? Because this is fixed, no, third one. You cannot change this. If I have got here 0, I have to write 0 only. There is no other option for me. Then what I will write dot 255. Now tell me why I will write 255. Block size is what? I am starting from where? If I will write here 256, how many value I will get? 257. See, when you start from 0, end at 256, how many value you get? 257. But how many we have to get? That's why we have to end it here 255, right? So here what happened? That here what you did, you have used here slash 24. And this is what? Classful. Why? Because this is a default subnet mask. And how many subnetworks you have got? Only one subnetworks. This is what? Network. See, this is what? This is network address. This is what? This is what? Broadcast address. First one is what? Network address. Last one is what? And whatever is coming in between them is called as what? IP address. So if I'm asking you 192.168.0.5, what you will tell? This is IP. Which network? 0.0. If I will tell you 192.168.0.100, what this is? IP. Which network? Dot zero. Now, what happened? I'm telling you that you have to send one message to all the IP addresses coming under this network address, that is 0.0. Option number one, what you will do? You will start sending to 0.1, 0.2, 0.3, 4, 5, 6, like that. Very complicated, right? So what is the best option? You send it to 192.168.0.255. Whatever the IP coming under that will receive that information. This is the use of the broadcast address. And in each class, in each subnetworks, we will be having network part and broadcast address. So first one is always is what? Network address, and last one is always broadcast address. And between them, what is that? IP addresses. So right, this is what? Broadcast address. You note down this point. Now see, here you have got only one network, no? This is my own network. I have used 24. Same IP, same thing I will use, but I will change this value. What I will use? 25. And then you will see how many subnetworks you will be getting here. Clear, no? Hmm. Block size. Why we are getting 256 here? This one, this 256 or this one? Last one, this one. See, when what you are doing here, you are calculating the range of each subnetworks. Means here, if I am starting at 0, I am ending at 255. So what could be the range, right? So here, according to block size, I got here 256. It means that you know that total range is what? Total IP address range. Forget about the octets. Okay, let's say I'm talking about the fourth octet. So each octet you have to fill it with what? Last should be 255. And you will start from where always? From 0. So if I'm starting from 0, if I'm ending at 255, what is the value I will be getting here? Always I will get here 256 values, right? The total value I'm getting is 256. If I have to divide large network into small network, I have to subtract the changes, no? Total is what? 256. That I know. Now what I will do, I will subtract the change is one. So if you will subtract here the value, what you will get? The number of changes. You will let me write 25, then it will be clear. Okay. Wait. For 24, it's clear, no? And see what will happen if you change the value. Same thing I will use 192. Now you write here, give ID class C classless subnetting 192 168 0.0 slash 25. That is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1. And rest will be what? Same 0. 1, 2, 3, 4, 5, 6, 7. Already 1 we have written, so 7 zeros will come, right? Next is what? 255 dot 255 dot 255. What is the value? 128. Okay. 128 is the value, right? Next, what you will do, you will calculate here block size. Block size is equal to 256 minus 128. That is value will be what? 128. Understanding now? Total is what? 256. What you did last is 128. You will subtract that. So you got that each network will be now of 128. Total is what? Total I have given you 1000 rupees. Yeah. Right? Next, what I am telling you that each person should get 100. It means how many person you will have? 10. Same thing you are doing. Total range you have got 256. Now each person should get 128. How many you will have? 2. Without calculating also you you can get the answer. It means according to slash 25, how many subnetworks I will get? 2 subnetworks, each of 128. And see, same thing will get. Now see what you will write here. Number of subnetwork is equal to number of subnetwork is equal to 2 to the power number of extra 1. Right? What I am writing, number of subnetworks is equal to 2 to the power number of extra 1. And how what is the value you got? 2 to the power. How many number of extra 1 we have? 1. So 2 to the power 1 is equal to what? 2. Number of host per subnetwork. What we are writing? Host also, but in each subnetworks, how many hosts we will get? That is 2 to the power number of zeros. How many zeros? 7. What is the value? 128. Okay. But you cannot use two things. See, whenever you write the range, first one is what? Network address. Last one is what? Broadcast address. So it means you have to subtract always 2 from that. Then only you will get what? Host address. That is called as IP addresses. So what you will write? Number of usable host. That is called as what? IP addresses only. Usable host per subnetwork is equal to 128 minus 2. That is going to be 126. Right? Now you start writing 192, 168.0.0, 192, 168.0 because till third octet it is fixed. Last one is what? Block size is what? 128. Now, if you are have to reach 128, you are starting from 0. What you will write? 127. because I am starting from 0. I have to get 128. It means I have to end at 127 to get 128. Again, next 192, 168 dot 0 dot. What comes after 127? 128. Next 192, 168 dot 0 dot. Always you will add this part, right? This one, first one. So 128 plus 127, 255. So right here 255. Then same thing we got to
Yes.
see what it is telling you. Number of hosts per subnetworks is 128. So, okay, first you see what is number of subnetworks. Two. How many you got?
Two.
One, two. Satisfied? Second is what? Number of hosts per subnetworks. The range is 128. I am starting from 0, ending at 127. What is the range I will get? But you know, I cannot use this. This is why. Network address. I cannot use this. Why? Broadcast address. So how many I will get? 126. This is what? Network address. This is what? Broadcast. So each subnetworks will be having network and broadcast. All right. Now, one question for you. IP is 192, 192, 168 dot 0 dot 100. Tell me the network address. 0. You only see and tell me that 0, 100 will come somewhere in between 0 and 127. Yes. If it is coming in between them, so this is my network address for this IP, right now. If I'm giving you one IP, 192.168.0.150. So what is the network address for this IP? This one, 192.168.0.128, right? It's not it. Note it down. And next question you try. You will try, then I will solve. Okay. 192.168.10.0/26. You try to solve this, then I will solve. This is the question. You have to solve this. You have to write all the subnetworks, everything. Find block size, find number of subnetworks, then find number of host per subnetworks, number of usable host per subnetworks. Then you write all the subnetworks also. This is the question. Then do it. Hmm. Correct, it is. Same thing you all have done.
Yes.
That according to slash 26, how many extra one we have? Two. So always you have to compare seeing the classes of the IP. That this IP belong to which class? Class C. Default segment mask of class C is 24. Here I have written 26. It means two extra will come. So if two extra I will write, I will get here what? 192. Then I will calculate block size. I will get 64. Number of subnetwork is equal to 2. Here 2 extra 1 we have. So 2 power 2 is 4. Number of hosts is equal to 2 power 6 because number of zeros are 6 only. And 64 we have got. And you know that we will be not using network and broadcast address. That's why we have to subtract 2 also. And then we'll get here what? 62. The starting range is what? 192.168, 10.0 till what? 10.63. Then 10.64. 64 plus 63, 127. Then after 127, 128. Then 128 plus 63, 191. Then 192. Then 192 plus 63, 255. Right? It means what we are doing here, what we add, this one plus this one, we will get this. This one plus this one, we'll get this. Right? See, here we are taking a slash 26. IP is also class C, then it is possible for you to write. If you will keep increasing the subnet mask, and let's say you are coming, you are from class A and taking the IP as subnet mask of class any other classes, then we will be getting so many subnetworks. So always no need to write all the subnetworks. You write first three and last two. That is fine. Okay. Next one. Today we have to complete Classful Subnetting. One more question you can take. This time we will take one public IP, not a private IP. So as you can see here, what is the range of the public IP for Class C? 192 to 167, and then okay. 200 dot 1 dot 1.0/28. Try this. Try this. Now see, okay, so it is /28. It means what? How many one we will get? 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4. And rest is 1, 2, 3, 4, right? It means 4, 1 and 4, 0 is we are getting here. So when you will write all the things, total you will get 255 dot, 255 dot, 255 dot, 240, right? Next, what will you do? Block size, right? That is going to be 256 minus 240. That is what? 16. Then number of subnetwork is equal to 2 power number of extra one. What is that? 4. So it means that 16 only, right? Next is number of host is equal to what? 2 power 4, right? Same 16. Then number of usable host. And you have to write one more thing here. Host per subnetwork. Okay. This is per subnetwork. Here also per subnetwork. Then what is the value you will get? 14, right? Then you will start writing 200.1.1.0. Then 200.1.1. See, this is 16. What we will write here? 15, right? 200.1.1.16. Then 200.1.1.16 plus 15. That is what? 31. Next 200.1.1.32. 200.1.1.32 plus 15. 47. Okay. You have to keep this writing. Keep on writing till what? 255. But no need to write. Just what we will write last one. So at last we will get 200.1.1.240 and this side 200.1.1.255. Correct? No? So this is going to be, this one is 16 subnetworks. How many subnetworks you have got?
60.
And this is what?
60.
16 subnetworks. Is it clear? Clear? So here what you are doing, always, if let's say, for example, if anyone is asking you, they tell me what is the number of subnetworks, then this method you can prefer also, and it is fine also. Okay, if anyone is asking you to tell me the number of subnetworks, so this method is correct. It's fine. But if anyone is asking you that tell me what is the network address for the IP 200.1.1.50/28. Someone has given you one IP 200.1.1.50 and /28. And what he is asking, tell me the network address for this IP. Again, you have to follow all these steps. You write this one, this one, this one, then you write some networks. Then after that, you will find, okay, somewhere this 50 will come into between this 32 and 47. So this 32 is going to be what? Network address. Then you will tell this answer, right? This is lengthy process. I want in a single line network address information. Okay. If anyone is asking you to tell me the number of subnetworks, then this method is correct. Fine. But you have to tell me only the network address, then this is lengthy process. So what is the next option? We'll use bitwise operation. See what happens in that. What we are using here now? Bitwise operation method. And see first, then you will write, okay? Now you have got the IP, let's say 200.1.1.50 only. Okay, take it 50 slash 28. Correct? Now you know that this first three of class C is fixed. First three octet. What will be changed? Fourth one. So what you do, you write 50 into the bit form. How will you write? 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, and 2 power 7 is 128. What I am telling you to write? 50, right? So you have to write 50. To write 50, are you going to use 128? No. 64? No. 32? Yes. 16? Yes. How much you got? 48. 0, 0, 1, 0. 50 you have written. Correct? Then you will write what? 28. 28 means what? 4 1 and 4 zeros. That we know. Okay. Forget this. 28. No. Forget this 28. What you will do? You will write this 240. 28 means what? 4 extra, na? You will write 28. So you will write, okay, this format you will use to write 28. Correct? Then you will get here at last 240. Right? 240 means what? 4 1 4 zeros. So write 1, 2, 3, 4, 1, 2, 3, 4. Done. Concept says if you have both side 1, make it 1. What does the concept says? Both side 1, make it 1. One side 1, one side 0, 0. Both side 0, 0. 0, 0, 1. Wait, wait. Yes, 1, 0, 0, 0, and 0. Got? Now you tell me what is the value of this number? 32 plus 16, 48. It means the fourth octet is what? 48. So it means after this, what will come? 200 dot 1 dot 1 dot 48. Then 200 dot 1 dot 1 dot 48 plus 15. 63, I think, right? No? So 50 will come somewhere in between this. And this is the network address of this particular IP address. Right or wrong? This is simple or not? Bitwise operation, what you have to do? First, you will write the last one into the bit form. Then you will convert this 28 into the, like how we are converting like the same. Right? Then you will write this 240 into the bit form. This all both side what you will do bitwise operation. If both side 1 will make it 1. If one side 1, one side 0, always 0. Both side 0 is always 0. Only one condition you have to remember, that is both side 1, 1. Right? Online students, clear it is? Tell me fast. Okay, so next question for you. You will try now, okay? And you will tell me using bitwise operation method. I'm giving you one IP, 200 dot 200 dot 1 dot 1 dot 100 slash 28. Tell me what is the network address? What is the network address for this particular IP address? And even this method we can use for class B also, for class A also. It is not that it is specifically for class C only. No, we can use this method for any classes. Just what will change? The method will change. Process will change. Method will be same only, but because in class B we are changing two octet, so there we have to convert the two octet into the bit form. And in this, as we are changing only class C fourth octet, that's why here we have to convert only fourth octet in class C. 96 is the answer. Okay. So first what we will do, same thing we'll write here. 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is what? 8, 2 power 4 is 16, 2 power 5 is what? 32, 2 power 6 is what? 64, and 2 power 7 is what? 128. Now what the value you have got? 100, right? So to write 100, you will not use 128, no? 64 you will use? Yes. 32? Yes. And rest will be 0, and this is going to be 1. Rest again will be 0, right? Then same thing, 240 you have to write because it is slash 28. What will you write? 1, 1, 1, 1, 0, 0, 0, 0. Next, you will use what? Weight-wise operation method. What it says, both side 1, make it 1, rest, please will be 0. This is 1, this is 1, rest is what? 0, 0, 0, 0, and 0. When you will calculate, what is the value you are getting? 96. 64 plus 32, 96. It means 200 dot 1 dot 1 dot 96 is the network address for the IP address. Note down this.
How about block structures? If we add the block size, we get.
Then we will get the broadcast address. See, but question will be generally network address because what we always use network address. Then written. Now let's start with class B subnetting. Class B, classful subnetting. Okay. Now in class B, let's say we have taken one IP 172.16.0.0 and slash 16 only because this is the default subnet mask of class B, right? So how will you write 16? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And 255 dot 255 dot 0 and dot 0, right? So you tell me 256, where you write for block size? So block size is equal to 256 minus 0. That is going to be 256 only. Correct? See, if I'm not writing that network part and host part because already I have written here, same thing will be there. Same value you will get for whatever we have written. That's why I'm not writing. Because here we will not get any subnetworks, but we will get only one networks, right? Because this is classful. So now you will write 172.16.0.0, then 172.16 dot. Now you tell me that in class C, what we change? Fourth. In class B, what we change? Third and fourth. So first, what you will change? Third. It is 0. Now, what is the value you got? 256, no? So what we will write? 255. What about the last one? 0 or 255? 255. Why? The reason the range is only says that the range of the IP is from 0 to 255. It means all the octet, whatever the octet can be changed, we have to fill that till 255. That's why we have to fill this also till 255, right? So it means what can be the IP? IP can be 172.16.100.100 also, 100.200 also. That's why here we what we will get more numbers of IP addresses compared to what we were getting in the class C. You just change and see the value. For example, if I am using here class B, classless subnetting. Same thing I will use. Just what I will change? The subnet pass. Wait. Class B, classless subnetting. 172.16.0.0. Let's say slash 18. Then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 16 plus 2, 18. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. 255, 255, 192, 0. Then what you will write? Block size. Block size is equal to 256 minus 192. What is the value of block size we will get? 64. Correct? Now, number of subnetwork is equal to 2 to the power number of extra 1. How many extra 1 you have? 2. It means total what you will get? Now you will write what? Number of host per subnetwork is equal to what? 2 to the power number of zeros left. How many zeros are left? No. 8 plus 6, 14. Total zeros, 14. Calculate and tell me the value. 2 power, wait. 14, 16,384. These many IP address you will get in each subnetworks. How many? 16,384 IP. Now, you know that number of usable host per subnetwork is equal to 16,382 because we'll subtract 2, right? Now you start writing 172.16.0.0, 172.63.255. Next, 172.16.64.0. 172.16.64 plus 63, 127 dot 255. 172.16 dot 128 dot 0. 172 dot 16 dot 128 plus 63, 191 dot 255. 172.16 dot 192 dot 0. 172 dot 16 dot 255 dot 255. Total range. Now you'll see why we are writing till 255. See, for example, if you have written here 0 and you have written 63, it means how many value you are getting? 64. Starting at 0, if you will end at 0, how many value? If you are ending at here 0 only, for example, what you will get? 64 only, right? But if I have changed that, and if I am writing here till 255, then starting at 0, ending at 255, how many value? 64 into 256, calculate. You will get 16,384 only. Same. And here also you have got the same. That's why you have to fill this also till 255 total range. And this is a total range of the IP also 16.0.0 and 16.255.255. Clear? You want me to take one more questions for this class B or will wind up?
You class A.
Class A will do tomorrow. That is fine. I'm asking for class B. One more question? Homework. Okay, fine. So class B is 128. So we'll take it. 150 will take. Fine. So write down 150 dot 0 dot 0 dot 0 slash 19. You try this. What you have to do? Find number of subnetwork. Then same host and usable host. And then write a first four subnetwork and last subnetwork. That's all. First four and last. Done. So that's all for the today.